Hello, and welcome back to our Spring Boot tutorial series. In today's video, we're diving into setter injection, a crucial aspect of dependency management in Spring Framework. Whether you're a beginner or looking to refresh your knowledge, this video will provide you with a solid understanding of how setter injection works in Spring Boot. Previously, we learned about constructor injection. In this video, we'll focus on setter injection. Let's first understand what setter injection is. Setter injection is one of the methods used by the Spring Framework to inject dependencies. This technique involves the Spring container calling setter methods on your beans after they are constructed, allowing these objects to reference other required beans. It's particularly useful when your dependency is optional or when you need to change the dependency at runtime. What actually happens behind the scenes? Suppose a setter injection controller requires a greeting service. And we use setter injection for dependency injection. First, Spring creates a bean of greeting service like so, greeting service equals new greeting service. Then, it creates a bean of setter injection controller equals new setter injection controller. After that, Spring calls the setter method to inject the dependency, setter injection controller.set greeting service. Why use setter injection? You might wonder why use setter injection? There are a few reasons. Let's begin with optional dependencies. Sometimes your class doesn't strictly require a dependency to function. Setter injection is ideal here because it allows you to either set this dependency or leave it unset, ensuring that the class's operation is not affected. This flexibility is crucial when dealing with optional components. Next, let's talk about circular dependencies. This is when two beans depend on each other to work. With constructor injection, this situation would lead to a failure because each bean waits for the other to be instantiated first. Setter injection, however, cleverly works around this by allowing the beans to be instantiated independently and set their dependencies later. Lastly, let's consider changing dependencies. In some applications, the dependencies of a class might need to change dynamically during runtime. Setter injection provides the flexibility to easily swap out one dependency for another as needed, accommodating changes without major disruptions. Moreover, it allows for the reconfiguration of bean dependencies without changing bean instantiations. In our previous tutorial on component exclusion, we added quite a bit of code and comments to our main class file. To keep our workspace organized and easy to navigate, let's begin today's session by cleaning up this code. This will make it easier to focus on the new concepts we're going to introduce. Let's start by opening our main class file. This is where we'll make the necessary changes and clean up our code from the previous sessions. Removing all comments and annotations located just above the main class, but make sure to leave the @Spring Boot application annotation intact. This annotation is crucial as it defines the entry point of our Spring Boot application and enables Spring Boot's auto-configuration and component scanning features. Removing the other elements will help us streamline our codebase for today's tutorial. In our constructor injection tutorial, we created the greeting service interface along with its implementation, greeting service impl, which contains the getGreeting method returning welcome to our channel. In today's tutorial, we will reuse the same greeting service class to demonstrate setter injection. Let's get started. First, we need to create a new class. Create a new class named setter injection controller. This class will be used to demonstrate how setter injection works in the Spring Framework. Add the @REST-controller annotation to the setter injection controller class. This annotation is important because it marks the class as a controller. Next, add private greeting service right below the class declaration. This variable will hold a reference to the greeting service that we'll inject using setter injection. Let's define a method in our setter injection controller that will use our greeting service variable. Create a public method named greetings. Calls the getGreeting method on the greeting service and returns its response. In our next step, we will annotate the getGreeting method to handle HTTP GET requests. Let's add the @getMapping annotation just above the method. This @getMapping annotation maps HTTP GET requests to the specified URL path /setter/injection/greeting. Now, let's define the setter method for injecting the dependency into greeting service using setter injection. This method will allow us to set the greeting service object that our controller will use. Now that we've set up everything, it's time to start our Spring Boot application and see our changes in action. Our Spring Boot application is now running on port 8090. Open your web browser and type in localhost 8090/setter/injection/greeting in the address bar. And press enter. We were expecting to see the message "Welcome to our channel" on the UI, but instead, we're encountering an error page. Let's open IntelliJ to check what's happening with this request. In the console logs, we can see that an error trace is printed. Let's scroll back through the logs to identify what actually happened. It looks like we've encountered a null pointer exception. As we look closer, we see that the greeting service is showing up as null. This suggests that the greeting service hasn't been properly injected into our setter injection controller. Oops, it looks like we forgot to add the @autowired annotation just above our setter method. Add the autowired annotation. This annotation is crucial as it instructs Spring to automatically inject the dependency. Without it, Spring won't know to perform any action on this bean. For setter injection, it's mandatory to specify @autowired directly above the setter method. This signals to Spring, "Hey Spring, call this setter method once the bean is instantiated with the required dependency for dependency injection." Restart the Spring Boot application. Now that our application is up and running, let's open a web browser to test it. Reload the page. And there we have it. As you can see on the screen, we're now getting the expected message, which confirms that our setter injection code is functioning correctly. Can we use a different method name for setter dependency injection? What happens if we use a different method name instead of setGreetingService? Will Spring inject the dependency? Let's change our code and check what happens. Let's rename our setGreetingService method to testSetterInjectionDemo and see if Spring still injects the dependency correctly. Restart the Spring Boot application to apply the changes we've made. Our Spring Boot application has started, so let's open a web browser to test it. Type localhost 8090/setter/injection/greeting in your browser's address bar and hit enter. Seeing the expected message confirms that Spring indeed injected the dependency, demonstrating that Spring can inject dependencies even when using a different method name. It means it doesn't strictly require a specific method name such as setGreetingService to inject dependencies, rather, it intelligently identifies the presence of @autowired annotations and the corresponding bean type to perform the injection. This flexibility allows developers to choose more descriptive or meaningful method names without compromising the functionality of dependency injection. In our case, renaming the method to testSetterInjectionDemo didn't hinder Spring's ability to inject the required dependency. This showcases Spring's adaptability and ease of use, making it a powerful tool for managing dependencies in Java applications. Choosing meaningful and descriptive method names is a good practice in software development. For example, if a method's purpose is to simply set a value to a variable, it's appropriate to use a setter method instead of a generic name like testSetterInjectionDemo. In Spring, the method name isn't the sole determinant for dependency injection, rather, it's the presence of auto-wired annotations that triggers injection. By following naming conventions and using descriptive names for methods, we maintain code clarity and improve readability. Spring's dependency injection remains effective regardless of the method name, as long as the method is properly annotated. This reaffirms the importance of clear naming practices in software development and highlights Spring's flexibility in managing dependencies. Now, let's revert our method name back to setGreetingService to follow standard naming conventions for setter methods. Let's discuss some best practices for setter injection. First, it's crucial to use descriptive method names for setters, like setGreetingService, to clearly convey their purpose. Always remember to annotate setter methods with it autowired to ensure Spring recognizes them for dependency injection. Keep setter methods public for accessibility by Spring during injection. Setter injection is ideal for handling optional dependencies, providing flexibility to your application. It's important to keep your setters simple, focusing solely on setting the field without introducing additional logic. This ensures clarity and maintainability in your codebase. When combining setter injection with other types of injection, such as constructor injection, it's crucial to choose wisely. Critical dependencies that are mandatory and immutable should be injected using constructor injection. This promotes clarity in your code and enforces the immutability of essential components. Like any technique, setter injection has its pros and cons. It promotes flexibility but can lead to issues if not managed carefully, such as accidental reconfiguration of beans in a complex application. Always weigh these aspects when choosing your injection method. That's all for our exploration of setter injection in Spring Boot. Remember, the right injection method depends on your specific scenario and needs. Experiment with different approaches to find what works best for your application. Thanks for watching. Please like, subscribe, and turn on notifications for more tutorials like this. If you have any questions or need clarification, leave a comment below. See you in the next video.